also have these double angle formulas. I don't know how much of those you want us to cover. Those are a little bit easier, I guess, to think about. But I figure we should start with half angles. Half angles are basically the harder ones to do. So this will be a little bit out of order because I want to make sure we do um, the half angles first because that's the most confusing for most students. So we'll start with that. We'll come back and do the double angles in a bit. So these are all half angle formulas, and they're all kind of this like draw the triangle type of problem here. So I'm not going to pick the most difficult one to start. I'll grab like the evens, and we'll talk about what could happen with some other ones. But so this is telling you the quadrant that you're in. Which quadrant is that? Is that? Which one is
Um,
pi over 2 to pi?
First quadrant. Oh, wait, no, second.
Second, yeah. So the triangle is this one. There's x. So tell me what goes in A, B, or C from this information here.
A is 5.
All right. How do you know it's 5 and
Oh,
not
wait, A
negative
is
5?
-5.
Yeah, there you go. So it's -5. What about C?
8.
All right. Now you don't actually need B, but just pretend for a moment like you do. What would the value of B be?
Um, √39.
Yes. Is it positive or negative?
Positive.
Okay, good. All right, now this is where we have to go back up and know those formulas for sine of x over 2. I doubt you're given those, so you'll have to memorize them. And notice they all rely on cosine. All right, so there's like two pieces to this. The first piece is the part inside the root. The second piece is the plus or minus. Okay, so we'll start with the part inside the root. So you already have the cosine value. The cosine of x is -5/8, like that. Like you didn't have to
Mhm.
draw the triangle, but that's an important thing to do because you might get problems that are more complicated than the triangle. Um, so is that okay?
Yeah.
All right. So you got to simplify inside there. So it's 1 plus 5/8. 1 is really 8/8 plus 5/8 over 2. This ends up being the square root of 11/16, and we'll reduce that in a moment. Now, the plus or minus, that's very difficult for most students. There are some rules to remember, but remember, theta is the angle is being cut in half. X is really being cut in half. Okay, so you're actually taking this inequality here and you're cutting it in half, in half, in half, which gives you pi over 4 less than x over 2 less than pi over 2, which puts you back in quadrant 1. Does that make sense?
Yeah.
All right, so that means in quadrant 1 is sine, the original one, is it positive or negative? Negative.
Positive.
It is positive. So that's how you decide this right here. And you don't want to guess. You want to do what I did here, which is divide the interval in half to see which quadrant you're in, which may not be the same as the one you started in, and that will give you the answer. So the square
Okay.
root of 11 over the square root of 16 becomes the square root of 11 over 4 like that.
Okay.
So give me just a moment here. So let's do another problem here. Just looking them over. Let's try 22. Um, let's try 22 here. And again, you don't have to draw the triangle, but I really want you to. So I really want you to make that part of what you're doing because it will help long term. Which quadrant are you in?
Quadrant 3.
It is quadrant 3. Yes. So the triangle looks like that. Um, that's theta. So give me the value of A, B, and C, please, in this triangle. A, B, and C.
Um, B is -4. C is 5.
Okay, and how about A?
-3.
-3. Good. Okay, now this time you do actually need the cosine of theta because the formula for cosine of theta does rely on the cosine of theta over 2 um, relies on that. So could you tell me the cosine of theta?
-3/5.
-3/5, good. And then I'm going to snip this in. Here we go. All right. So this is now plus or minus 1 minus 3/5 divided by 2. Could you simplify inside the root for us, please?
2/5/2. 2/10 equals
You got
plus or
root.
minus √2/5. No, wait,
No,
no.
no.
Never
The
mind, that
one,
wouldn't work.
well, it becomes it's 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 two I mean it is √1/5. That's fine. Let's deal with the plus or minus now. So divide each of these by 2 and then tell me which quadrant you're in. Which quadrant is that?
Quadrant 2.
And what do you know about cosine in quadrant 2? Is it positive or negative?
Negative.
It's negative. So the answer here is negative. Now, do you remember how to rationalize or reduce the square root of 1/5 like this?
Um, it would just, would that not be the answer?
I mean, it is, but it isn't. It's like, let's let's do it this way. How about that? Does that help?
Yeah.
All
Oh, wait,
right.
no, √1 would just be, but we can't leave √5.
Yeah, so you have to multiply the top and bottom by √5.
So then it'd be -√5/5.
Yeah,
Could we not leave it as -√1/5?
not preferred.
Okay.
Okay. Let's try another one here. Hopefully you're getting the feel of these. 24. All right. All right. So which quadrant are you in for this one?
Quadrant 2.
Quadrant 2. Yeah. So um this is the triangle.
Hmm.
Here's X. Give me all three values for A, B, and C with cotangent.
A is -3, C is 1, and then B would be.
Well, this is cotangent though. Cotangent is not cosine.
Oh, sorry. Cosine over sine. B, wait, inverse of. Oh. A would be -3, B would be 1.
Right? Why isn't it the other way? Why isn't it that B is -3 and A is 1?
Because it's the inverse, because it's cotangent,
Yeah, it's the
not
flip.
tangent.
Okay, so what would C be?
Um, √10.
Root 10. All right, good. Okay, now when so now you need to find the cosine of X. What would the cosine of X be?
Uh, root -3 over √10.
All right, so that becomes √10 over √10. So this is -3 square root of 10 over 10. For that, it is good to rationalize. So now we can go grab our formula for cosine X over 2. So this is plus or minus square root of 1 minus 3 square root of 10 over 10 all over 2. To determine the plus or minus, which is now easier than the inside part, again, you got to cut this in half. And you'll start noticing a pattern here, that it generally moves one quadrant. So you were
Mm-hmm.
in quadrant 2, now you're back in quadrant 1.
1.
That's not always true, but um, so let's let's talk about how to reduce this. So the cosine is negative there, so we know that. So to reduce this, um, you're going
Wouldn't
to
the
make a
cosine
comp
be positive?
in,
Quadrant 1.
sorry, yeah, it is positive in quadrant 1. Thank you. So 10 minus 3 square root 10 over 10 over 2. You would just apply that 2 to the two bottom numbers. And the reason is because you're multiplying by this right here. So let's see if we can make that happen here. Uh, okay, so that becomes 10 minus 3 square root of 10 over 20 over 20, like that. Is that okay?
Yeah.
And then like this one, it's like, well, what do you do to simplify it? You're supposed to make a common denominator, which is the 20, but then you're taking the square root of the top and the square root of the bottom. And this is where it's really not trigonometry anymore. It becomes kind of a terrible algebra question. Let me just come off the side here. Like you might want to ask your instructor about what to do from here. The square root of 20 becomes 2 square root of 5. And so you could multiply the top and bottom by the square root of 5, which gives you the square root of 50 minus the square root of 50, 3 square root of 50 over 10, like that. And then this 50 inside here reduces to 5 root 2. So it becomes 50 minus 6 root 2, square root of that over 10. it's really bad to leave square roots inside square roots, but that is the best we can do for this. So it becomes a lot more
Okay.
about becomes a lot more about um, simplifying these awful radicals than anything else.
Okay.
All right, is that clear?
Yeah.
All right, fantastic. Um, so the next thing in your list here, maybe we should try one more. Maybe I should have you try one. Yeah, I should have you try one. We didn't do any in quadrant 4, which is a little weird. So let me make one up here. Let's say you wanted to find the tangent of x over 2, and you're told that the cotangent of x equals -4/3, and you're in the fourth quadrant. So 3 pi over 2 less than x less than 2 pi. So could you attempt to find all three sides? And what you're really like out of all this is you're supposed to figure out the cosine of x out of all that.
S- So find they're two separate questions.
You can't if you look at all the formulas for half angles, what do you notice about all of them? What do they all require you to find?
Sine, cosine, or tangent.
No, they all require cosine.
Oh,
So no matter what they give you, like whatever they give you, like our goal is to find the tangent of x over 2. You have to find cosine of x to be able to do that.
okay.
So when you're drawing this triangle, it's all in an attempt to find cosine of x. So what I'm asking for here, just again to be clear, is I labeled the triangle. We want to figure out what cosine of x is out of this triangle.
Yeah.
Okay.
Um, 2,
What are you giving me? What is two?
the answer.
For everything?
Yeah.
Okay, I have no idea. I was going to work through it with you. So that if this is X, this is -4, this is +3, this is 5. Does that match your triangle?
Yeah. Oh
Okay, and then
wait,
cos
no, I
right.
flipped
So
2 again.
that is the most important part of this. If your triangle doesn't match that, oh, actually, I gave you the wrong one. It's 4, -3. Mess
Okay,
that
yeah.
up here. And so cosine is 4/5. And that's the most important part here. If you can't do that, you're really stuck. So this becomes plus or minus 1 -4/5, 1 +4/5. You have that written down.
4/5?
Cosine of x is 4/5.
Oh, wait 1 second. Is it 1/3?
Again, I don't know, but this is 1/5 over 9/5.
Nine
Did
fifths.
you get something like that?
Yeah.
Okay. And then yeah, so the bottoms cancel, so it's 1/9 plus or minus square root of 1/9, which is 1/3. Now, to decide whether it's positive or negative, you go back to the original restrictions here and you cut everything in half. Divide by 2, divide by 2, divide by 2. That's pi, that's 3 pi over 4. What quadrant are you in?
I said second.
That is the second quadrant. And what do we know about tangent in the second quadrant? Is it positive or negative?
Positive.
Tangent is
Whoops.
negative in the second quadrant.
Because it would be 0 over -1, which is 0.
No, tangent is sine over cosine in the second quadrant. I mean, it's always sine over cosine. In the second quadrant, the sine is positive, but the cosine is negative because it's the x.
Oh, okay. So it'd be -1/3.
And like in my classroom, the sine would be 50% of the answer, uh, because it is that important. Okay. We should switch to some double angles now, which are not quite as difficult, but worth covering here. Um, so there are double angle formulas for sine, cosine, and tangent again. You'll have to memorize those
Hmm.
if you haven't. Apologize, they're terrible. These are, I mean, it shouldn't be emphasized, but that's what they have here. So here we go. Sine's the easiest one. Sine of 2x is 2 sine x cosine x. Cosine 2x comes in 3 flavors. Depending on the situation, you decide which one to use, but these are easier than the angles for whatever reason. So let's look at some problems here, which I'm not seeing. Uh, wow. Um, so the problems are kind of similar to these. Like I'll just make up one here to start. So it would tell you would see like figure out the sine of 2 theta if tangent of theta equals -5/12 and 90 less than x less than 180. So these are kind of the same types of problems that we just did, except we're doing them with double angle formulas. So you're gonna have to draw that reference triangle. Sorry, this is theta, not x. And then could you tell me what A, B, and C are in this situation?
E is 5, A is -12, and C is 13.
13, yeah. So then you have to know, okay, the sine of 2 theta is 2 sine theta cosine theta, which means that you need sine of theta and cosine theta.
Sine theta is 5/13, and cosine theta is -12 or 13.
Job on that. So you could simplify this. Let's see, -120 over 169, and that is your answer. So that's the easy one. The cosine of 2 theta is the more difficult one. I could ask you for that and tell you that like the cotangent of theta is 1/3 in quadrant 3. Like sometimes it'll just tell you which quadrant you're in. So when we go back to our formulas here, let me snip these in. You can see, actually, let me snip the cosine ones in. You can see that there's 3 formulas for cosine. It's like, well, which one should you use? And it depends on the problem. Like sometimes it'll be obvious. You can derive all of them from the first one, but that's a lot of work. Um, I don't know what to tell you. You will reuse these in calculus too. Most students forget them by then, but you will reuse them. So um, anyway, why don't you draw the triangle, the reference triangle here, and label all 3 sides and figure out what. Let's just use let's use the first one here. Why don't you figure out what sine theta is and cosine theta is? And that's reference triangle down here.
-8/7.
Are you giving me a final answer?
Yeah.
Okay. So it all comes down to the triangle. This is negative. Oops, I have that wrong. This is a -3 over -1, and this is the square root of 10. Does that look like your triangle?
Is it not √7?
It's this squared plus this squared when it's the two. It's the A and the B.
Oh, Oh, I did times instead of squared, sorry. Um, it would just be negative 4/5 then instead of 8/10.
So well, yeah,
7.
so the sine of theta is minus 3 over square root of 10, and the cosine of theta is minus 1 over the square root of 10. So if we use the first formula, you're squaring, so negative 1 over 10, sorry, it's root 10. You're squaring that minus 3 over square root of 10 squared. So that's 1 over 10 minus 3 over 10, which is minus 2 over 10, which is minus 1/5.
Yeah.
Okay, great. All right. I guess I should make some comments on some other stuff here. Um, like the first few problems are just using the formulas we just talked about for, like, these should be very straightforward now that you know the double angle formulas.
Mm-hmm.
Um, just be careful that you know whether you're doubling or halving. It's easy to mix them up. So like number one looks like this formula here, this one right here. And notice that the the theta is not the 2 theta. So this is number one is equal to the cosine of 30 degrees, which is a value that you're supposed to know. You're supposed to be like, oh yeah, that's square root of 3 over 2, that whole unit circle top. Number two looks like this one down here. And then it becomes the tangent of 30 degrees. It's double the given angle. Okay. Stuff like that. So these should be really familiar to you now, maybe. We can also, I guess you didn't get those with half angles, but those are
How'd you immediately get that it's tan 30?
um, because the theta is 15 in that problem,
Oh, okay, yeah.
and we want 2 theta. It
Okay.
also tends to be a number that you can find on the unit circle. So like in number 3, you don't 22.5, we don't know, but double that we do. And that's what the formula says here. It says, okay, theta is this 22.5. This is equal to the sine of 2 times 22.5, which equals sine 45. Now, some instructors do a problem like this, which is really deceptive. They'll do like the sine of 15 degrees, cosine of 15 degrees, and you'll look and look and look and you'll say it looks so much like that, but it's missing the 2, right? It looks like that first one.
Mm-hmm.
So what you have to do here, and this is not obvious, is you put a 2 there, but you also divide by 2 so that the top is what you want, but you divide your final answer by 2. So this becomes, the top becomes the sine of 30 degrees, but that 2 also comes down with it. The other type of problem you'll see is something like where it's 4 sine 75 degrees, cosine 75 degrees. And it looks a lot like this formula here, except there's a 4 instead of a 2. So you make it 2 times 2, sine 75, cosine 75. And this part is that identity. So that part in the box becomes sine of 150 degrees, which is on the unit circle, and then you bring this 2 down with it. So the sine of 150 is over here on the unit circle. It is 2 times 1/2, which equals 1.
Okay.
All right, so we do unfortunately have to stop here. I do need a break, otherwise I'm not good for anyone. But hopefully this helped.